The next rule says that if you have a fractional index like this, when the numerator of the fraction is not equal to 1, then you should change it accordingly as a raised to 1 upon m raised to m, or you could also write it as a raised to m raised to 1 upon m. So basically the index over here is changed into two factors, m and 1 upon n. Now it is up to us whether we want to apply this fractional form first or we want to apply this m first. So if we apply this 1 upon n first, we would get this sort of form. And if we apply m over here first, then we would get this sort of form. So it all depends on the base that we have. How we can easily simplify the base, we would choose one of these forms. So if we apply this form, then it would become nth root of a raised to m. And if we apply the second form, then it would become a raised to m within nth root. Now to apply this, some of the questions are written over here. 64 raised to 2 upon 3. Now this 64 can simplify this 3 which is written in the denominator of the index. So first of all, I'm writing 64 raised to 1 upon 3 whole square. And 64 is basically equal to 4 cube. So 4 cube raised to 1 upon 3 whole square. Now, both the indices would get multiplied by each other first so that we can simplify the fractional part of the index. So 3 into 3, 3 into 1 upon 3 whole square. 3 gets cancelled with 3. We are left with 4 raised to 1 square. So when we apply that square over 4, we get 16 as the answer. So this is how this complex index was applied over here, and a simpler answer was found. For that, we changed this index into 2 multiplied by 1 upon 3. And then this 1 upon 3 was applied over here and 2 was written as the outer index. Then we changed the base accordingly so that we can simplify this fractional index. And when we got the answer within the brackets, that outer index was applied on the base and the final answer was equal to 16. Now, the further application of this, let's move on to the second part, which is 32 raised to minus 3 upon 5. Now, first of all, the sign of the index should be made positive. And for that, I'm moving the whole term in the denominator. So it becomes 1 upon 32 raised to 3 upon 5. And power would be changed into two forms. It would be written as 32 raised to 1 upon 5 multiplied by 3. Now, that 1 upon 5, I'm applying it over 32 first, and then I'm writing a 3 over here. 1 upon 32 should be changed accordingly so that we can simplify this 1 upon 5. And to do that, I'm writing 2 raised to 5, which is equal to 32 raised to 1 upon 5 whole cube. And now these two indices within the curly brackets would get multiplied with each other. So 5 into 1 upon 5 whole raised to 3. 5 gets cancelled with 5. We are left with 2 raised to 1. And the cube is applied over this base. So the final answer of this comes out to be 1 upon 8. Now, the next part is where we have a decimal index. And it is 100 raised to 1.5. Now, these indices are simplified by first converting them into a fraction. So it would become 15 upon 10. And when we simplify them, it becomes 3 upon 2. Now, I would change this index as 1 upon 2 multiplied by 3. And it would become 100 raised to 1 upon 2 raised to 3. Now, to simplify this thing, I would be changing this 100 into 10 square raised to 1 upon 2 whole raised to 3. And now these two indices would get multiplied with each other, 2 and 1 upon 2, so that we can simplify them. So it becomes 10 raised to 2 into 1 upon 2 whole raised to 3. And if we cancel this 2 with 2, we get 10 raised to 3. So the final answer we get over here is 1000 for this part. Okay, now let's move on to the next one. It says that we have a cube root of a raised to n. Now, the cube root means that we have a power of 1 upon 3 over a raised to n. Now, both the indices, if they are multiplied with each other, we would get a raised to n upon 3 as the final answer, which is written without the surd form. Now, the next part is 1 upon 5th root of x square. 1 upon 5th root of x square. So it would be x square raised to 1 upon 5. So this is how the surd form is changed into simpler form, and the vice versa of that we have also discussed.
We try to explain complex concepts in simple language and with effective examples. If you like the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.